Okay, welcome to part 3 of Introductory FLAC3D training. This video will be about the model pane. So if you've been following along, the videos so far have covered introduction to the user interface, grid generation in Sketch, and this one is about the model pane. So if you followed along and created the model in Sketch and extruded it, you will now be looking at the model pane, which looks like this. Before we get into using FLAC3D here, I need to go over some concepts. The model pane is mostly about selecting things so that we can use them later. And to understand the meaning behind selecting things and why that's useful, we just need to go over a couple of important concepts. Okay, the first one is ranges. So almost everything that you do in FLAC3D acts upon a range. So some number of zones or grid points or faces or something like that. So when we look at the commands, you'll see that there's a range keyword that is used to identify different parts of the model. If you don't give a range keyword, it acts on everything in the model, which sometimes is fine, most of the time is not fine. A range is a filter that checks to see if the object should be included. So essentially, almost all the commands have a loop in there. So it loops through all of the objects, let's say zones, checks if they're in the range that you specify, and then does something to them. You can daisy chain these things together, so you can have multiple ranges to create more complicated things. And I'll just show that on the next slide. So, for example, the simplest possible range might be the X position of something, in this case, a zone. So if the centroid of the zone lies between a coordinate of 2 and 3, it will be selected. So you can see here the top picture. It's just, imagine this is that brick that we created that goes from 0 to 10. It's just selecting the zones that have an X coordinate between 2 and 3. You can do the reverse. You can choose all of the zones that do not have an X coordinate between 2 and 3 by just using the not keyword. You can, again, daisy chain these things together. So you can say range position X 2 to 3 and position Y 2 to 3, and it will only pick up the zones that are included in both of those ranges. And if you want the opposite, you just use the keyword union. So range union, position X 2 to 3, position Y 2 to 3. Sorry, it's not the opposite. It's the union of those ranges. So rather than ones that just fit in those two ranges, which would be like an and type of thing, this is more like an or type of thing. If it fits in either one of the ranges, it gets selected. So this slide is showing you the commands. The point of the model pane that we're going to show in a minute is that you don't necessarily need to use the commands. You can just click on things and use the mouse and select ranges in a more sort of interactive way. So there's all kinds of different ranges. This is position, but there's different things. And one that's very commonly used is groups. We touched on this already in the sketch tool. You were able to select certain parts of the model and assign them a group name. Remember, we picked on some of them and said bench 1, and some of the other ones and said bench 2, and some of the other ones and said tunnel. So assigning names to zones is pretty straightforward. There's nothing confusing about that. However, it starts to get a little more interesting because each zone can actually have more than one name. And this is necessary. You know, in the old days, the zones used to just have one name, which was fine. But it turned out that people wanted to assign more than one name to a zone. And for a use case, imagine this. You have assigned geology names to your zone. So maybe this layer is called sandstone, and this layer is called silt, and this layer is called mudstone or something. But now you need to make an excavation called tunnel. Well, how can that zone be called tunnel and siltstone at the same time? And so what we did was invent this idea of slots. And this allows you to have multiple group names for each zone. And so what they do is they have a different group name in each slot. And so here's an example. You can have actually up to 128 slots. So here's sort of a contrived example. Zone group Fred, slot A, range position X 2 to 3. So these pink ones plus this green one here are called Fred in slot A. Zone group George, slot B, range position Y, 2 to 3. So all these yellow ones plus the green one are called George in slot B. And this green one has two names, right? It's called Fred and George. And so if we plot all of the possible permutations of different groups, we have pink ones are just Fred, yellow ones are just George, and the green ones are Fred and George. So you can see how this would be useful. I mean, this example is a bit made up, but you could say, you know, some of these are sandstone, and some of them are also called tunnel, and some of them might also be called, you know, wet or something like that. So this is again about commands, and you know, you can do this in shorthand by saying zone group A equals Fred, which tells you the slot and the group name in one command. Again, you don't necessarily have to memorize these commands. We're going to use the model pane to identify groups in these things. And once you have group names, then you can use them in ranges. And so this is a lot easier than trying to come up with these crazy daisy chain ranges like X is something, Y is something, Z is something. We can just identify them as group names and then use that as the range. So range group Fred, or you can be more specific, range group Fred in slot A, and things like that. Note that if I just say range group Fred, it will search all the slots. So most of the time, I don't actually have to be specific about which slot I'm talking about. Because if I say range group sandstone, it'll find all the sandstones. Or if I say range group tunnel, it'll find all the tunnels. It doesn't really matter what slot it's in. You only have to be careful if you're using the same name in different slots, which is probably a bad idea anyway. One last thing to say about groups before we get to the model pane. There's a hierarchy of groups. So in the previous examples, I've been assigning group names to zones, and then I can do stuff to them. So for example, zone, initialize stress, something, range group, sandstone. Sometimes I want to act on things that are not zones. So maybe I want to act on the faces, like apply a stress to the face. So I would say something like zone, face, apply, stress, something, range, group, something. The faces themselves can have group names, which is fine, but it will also check the group names of the host zones, right? So if I say range group sandstone, and I'm applying something to a face, maybe the faces don't have a name called sandstone, but the zones do. And so we'll find all the faces on all the zones called sandstone and apply a stress. And the same thing is true for grid points. So if I'm doing something to a grid point and it doesn't have a group name, it's going to check the host face, and then it's going to check the host zone and see if that group name exists. So you don't necessarily have to apply group names to all the faces and all the grid points. If you apply them to the zones, and then you try to act on the faces or the grid points, it will sort of go up the tree and look to see if there's an associated group. This is kind of an advanced concept, but it will be useful in the future. Okay, let's go back to FLAC3D and start looking at this model pane. And again, the model pane is mostly about finding ranges and assigning group names to things. There are other things you can do in the model pane, and we are gradually adding more and more functionality. But for now, it's mostly about groups. So let's have a look at it. So here we are. Assuming you're following along from before, you should be looking at this model pane right now, and it should look like this. This is showing zones, and they're colored by group. So you can see over here on the right-hand side, it says colored by group. We got a whole pile of different colors here. If you look under color labels and scroll down, you can see there's probably 60 or 70 different group names here. And what's happening is there are different groups in different slots, and it's showing all the possible combinations of those things. So the way that the sketch works is that, so let's just look at the end of this now. Pretend we're in Sketch and we're looking at this 2D section. Every one of those four-sided blocks that we've created in Sketch gets its own group name. Okay? Those group names are stored in a slot called block. Okay? So these are all the block names that are automatically assigned by Sketch, and they're very unimaginative names: block 1, block 2, block 3, block 4, and so on. okay? But this potentially could come in useful. Now, you can see that all the way along here, they have the same names. When we extrude in Sketch, remember, you can have different segments in the extruded view, and those also have group names, but they're in a different slot, and this slot is called segment. Right? So remember when we extruded this thing, there was the default section that was 100 meters long, and then we added a couple of points to make some more sections, and each one of these sections, by default, gets a group name, and again, not very imaginative, but the group names are segment 1, segment 2, segment 3, segment 4, and so on. Okay? So right now we've got a whole bunch of different group names just with the segments and the blocks. We've already got a combination of 4 times whatever, how many blocks there are, right? Now, also remember that we assigned some group names by hand, and those group names go into slot construction. So if I choose slot construction over here, I can see the group names that I assigned by hand. So remember, this red one was bench 1, this was bench 2, this pink layer is called tunnel, and everything else I didn't assign, so it's just none. And remember, we did it in a 2D view, and so all of the zones in the 3rd dimension get those same group names. Finally, recall that we picked a small segment in the top-down view and give that a different group name, and that goes in slot extrusion. Right? So there was this little segment here that we called tunnel when we did the extrusion, and so this is the by hand. So when you create a sketch, model in Sketch, you automatically have 4 slots, right? You have the block slot, which is automatic. You have the segment slot, which is automatic. You have the construction slot, which you assign by hand. And if I didn't assign anything here, it would all just be none. And I have the extrusion slot, which I assign by hand. And if I didn't say anything, it would all be none. So we have all of these different slots. And we can look at each one individually, or you can go back to any, and it gives you all the possible combinations. Now, okay, that's fine. Now, what do we do with this? The point of the model pane is to be able to select things and do things with them. So by default, if I click on something, it will select by color. So that's why having these different groups is useful. So if I click here, it's going to select all the zones that are that blue color. If I click here, it's going to select all the zones that are that light blue color. You can add these things together by holding down Control. So I can click on blue, hold down Control, click on light blue, hold down Control, and click on red. Now that I've selected them, what do I want to do? I can hide them. Right? So one of these buttons up here is hide the selection. So I can hide them, and I can drill down and look inside. And this is useful in 3D models because often interesting stuff is happening inside. In this model, it's not very exciting. But you can imagine that having the ability to drill down and look inside is totally useful. Once I've hidden these things and I want to bring them back, I can go up here to this thing with the 4 squares and say show all. Note there's keyboard shortcuts for all these too. I'm not going to use them, but there are definitely people who like to use keyboard shortcuts. So if I've gotten myself in a pickle and I want to bring them back again, I can just say show all. Here they come back again. And I could actually do the opposite. Select these 3 again and hide everything else. So this one is hide the selection, but this one is hide everything else except for the selection. So I can do that too. Okay. So let's bring them all back again. So again, by default, it's selecting everything by a single color. If I wanted to, select the whole extruded segment of, say, bench 1, I can change this group slot to show the construction slot, and I can choose all of bench 1 and do that kind of thing. Instead of choosing by color, I can actually choose individual zones. So if you really wanted to get into the details of this thing, you can choose individual zones by holding down the Alt key. So if I hold down Alt, I can choose individual zones. And again, if I need to choose more than one, I hold down Control and Alt, and I can choose a bunch of them. And the rest of the functions are exactly the same. I can hide them, hide everything but them, and so on. Okay, so what can you do when you select things? So let's go back to any. If I select a segment here, there are things that I can do to it. So this little drop down here at the end, I can give it a different group name. So maybe I want to combine a bunch of these things and give it another group name to make life easier in the future. I can assign a constitutive model, right? So I could go in here and say, I want this to be more Coulomb material. And then once I've assigned a material type to it, I can go and assign properties, set model properties. So it knows that it's more Coulomb. These are the properties that it needs. I can fill in these numbers. There's also this concept of a database. So you can load up a database that we give to you, or you can save the set of properties in your own database. I won't go into that now. We look at that a little bit in one of the advanced examples. But certainly it's possible to assign constitutive models and properties, which is nice because you don't need to, memorize all the commands for all the different constitutive model names and property names and so on. And it also shows you which properties are available for each constitutive model, which is useful. Okay, we're not going to do that here. In this simple example, everything is going to be the same type of material with the same properties. So we could do this, or we could just use a command that we'll show later. But you can assign group names, you can assign constitutive models, you can assign properties, and you can even densify, which I'll show in this example in a minute. Before we get to that, so far everything we've talked about has been related to zones. You can also mess around with the faces. So see up here, there's a drop down here. Right now we're looking at zones. We can choose something else. There's all these structural elements. So you could, in theory, mess with shells and liners and beams and so on. But for now, let's just choose zone face. So the zone faces don't have any group names associated with them. Recall that in the sketch, we could have clicked on an edge and gave it a group name. And then when it gets extruded, the face names will assume that group name. So we could have done that in the sketch. We didn't. So what we have is a bunch of faces with no name. This works the same way as the zones, right? So by default, if I click on something, it will choose by color. So if I click on this, it will choose all the faces because they're all the same light blue color, okay? This is almost certainly not what you want to do. Probably the reason for choosing faces is that you want to give them group names so that I can apply boundary conditions later or something. What I probably want to do is just pick maybe these ones on the front or maybe these ones on the side, give them some name so that I can apply boundary conditions to them. So instead of choosing by color, I want to choose based on some break angle. So see these little arrows here? This one says, select faces on a plane defined by a break angle. And by default, this break angle is 45 degrees. So what that means is it will select all the faces until it finds an angle of more than 45 degrees, and then it will stop selecting. So if I choose this tool here and click on this face, right, it only chooses the faces here because there's a break angle of 90 degrees here, 90 degrees here, 90 degrees here. So I've only picked up these faces here, which is usually what you want to do. And once I've picked off these faces here, I can give them some group name, right? I can call them side or east or something like that. And note here, we've got this bend. If I click on this face, because this bend is more than 45 degrees, it's going to select everything on these two faces, right? If I only wanted to select this face here, I would have to change this break angle to just select this face. But by default, it's 45 degrees, so it's going to choose this whole thing. And again, I could go here and assign a group name to the faces. Now, we'll not do that because there's a handy built-in tool that kind of does this for you. And so I'll show that right now. So if we leave the zone face plot and we go back to zone, so now we're back to looking at zones, and I'll have these crazy group names. We can automatically assign face names based on the break angle. Okay. So instead of trying to identify each of these faces individually and assigning group names by hand, it will just intelligently look at the break angles and assign face names to them to be used later when we're doing boundary conditions. And to do that, you just click this little tool here. It's an A in a box, and it says assign group names to faces automatically. So I click on this. Most of the time, you probably want to check this box for ignore existing group names. If you don't, then every one of these faces that's a different color will have a different face name, right? So this would be like East 1, East 2, East 3, East 4, East 5, East 6, and so on. And that's kind of a mess. So if you ignore the existing group names, it will just use the break angles, and you're good to go. So I hit assign groups. It pops over to the zone face plot. And now it shows me the color labels for the different groups. So the top is top, and this is called west, and this is called south, and so on. You can see that it automatically assigns these names and puts them in a slot called skin. So recall how the different groups can have different slots. The faces can also have different slots. And by default, when you do this automatic grouping, they go into a slot called skin. It's not really important because, again, when I use the commands later, I don't necessarily have to say the slot. I can just give the group name and it will work. But just so you know, they're in a slot called skin. Okay, so that's totally useful. And we'll use those names later when we're doing boundary conditions. The last thing we're going to do is densify some of the zones. So let's go back to the zone plot. Okay, so here's our tunnel here. This little green square here. Okay. Just quickly to reassure ourselves that we're doing this correctly. If we look at the construction view, the tunnel is this pink part actually doesn't pass all the way through the blue, so we can't see it on this face. But it's basically the middle of this blue part here. And if we choose the extrusion slot, we can see it's this part here. So if we go back to any, well, this little green square is representing the tunnel. Actually, the tunnel will not go all the way through to here. First, we'll delete the benches, and then we delete the tunnel, but that's fine. For now, we can densify everything around this tunnel. If we leave it like it is, we're not going to get very good results here. We're going to excavate this tunnel, which is only one zone. We've got these giant zones around it, so we're not going to get a very nice stress distribution or displacement calculation around this tunnel. We need a little bit more density here. And so one of the things we can do in the model pane is densify the zones. Now, what we want to do is select a region around here to densify. They all have different colors, so we can't really select by color. We need to use some other kind of range. And so if you look down here on the right, there's different ranges that we can use. And so these correspond to some of the ranges I was talking about in the PowerPoint. We can choose, for example, position X. If I choose position X, double click on it, I can do this graphically, right? It's showing me the limits of the range, and I can just grab these things and drag them along, right? And so now it's going to select, as soon as I hit select, it will select all of the zones that have a centroid between these two semi-transparent planes here. So if I choose select, you can see that worked, right? I can hit trim selection and it actually hides everything else. Oh, sorry, that just got rid of the selection. I was wrong. Select, hide. Sorry, hide is what I wanted. That actually hides the selection. All right. We don't actually want to do that. So let's bring them back. Let's go to position X again. Now, instead of dragging these things along, you could type numbers in here if you wanted to be more careful. So these are editable. I can type in numbers here. I lost my other one. Hold on, where did it go? Oh, it's just inside. Okay. And again, just like we did when we were choosing zones up here by group, instead of selecting the ones inside of that range, we can select the ones outside of that range. So I can just choose not, and then I can choose select, and then I can choose hide, and then we just leave the ones that are in here. Right, so there's all these different ranges here: position X, position Y, sphere, cylinder, and so on. So let's bring those back. So what we're going to do is draw a rectangle around this. Draw a rectangle around this tunnel and densify the zones here. But we could just do that now. It would be okay, but it would be slightly weird because what happens is if we draw a rectangle here, we're looking at a perspective view. And so it doesn't really know how to project that rectangle into the third dimension. It kind of gets bigger or smaller as it projects into the third dimension. So if you want to do this accurately, what we need to do is change the view here. So right now it's showing perspective view, where things get smaller off into the distance. We want them to be constant, so we change this from perspective to parallel. Now this kind of looks a bit weird to the human being because they are now not getting smaller into the distance. But this is useful for doing these like rectangular ranges. So I zoom in on my tunnel here. And I want to create a rectangular range. So I go in here and choose rectangle. I can just draw it. And so we don't have to be super accurate here, but let's say we want to take roughly 3 zones on all sides of this tunnel for densifying, right? So we'll start up around here somewhere, here, let's say, and then we'll draw a rectangle somewhere like this. Unfortunately, the edges of the zones kind of disappear while I'm drawing my rectangle, so I kind of have to guess. But I do that, and let's have a look. So I've got about 3 zones on this side, about 3 on this side, about 3 on this side. Remember that it does it by the zone centroid. So let's just hit select here and see what happens. Okay, maybe I've got a few more zones than I wanted, but that doesn't really matter for the purposes of this thing. We can also look, if you go here and spin it, you can see that that rectangle passes all the way through. So it's selecting zones all the way through in the 3 dimensions here. And it's doing it intelligently because it's in the parallel view. So, okay, I'm happy with that. I can just close this rectangle selection box. I've selected a bunch of zones around the tunnel. Now what I want to do is densify. So that's one of the tools up here. So I go to this dropdown. I choose densify the selected zones. I can choose the number of segments. So by default, it's going to split them in 2 in the X direction, 2 in the Y direction, and 2 in the Z direction. So every zone will turn into 8 new zones. I can make this even denser if I want to. I can make it 4 by 4 by 4 so that every zone turns into 64 zones. We will not do that here. All we're going to do is do it 2 by 2 by 2. So we hit densify. It thinks about it for a few seconds. And there we go. So let's turn off the selection. There we go. So now you can see we've got denser zones around the tunnel and less dense zones out here. And also what you'll see, and if you're like a finite element person, this is slightly disconcerting, is that you will see here you've got 2 zones adjacent to 1 zone. And so you've got a node just hanging here that's disconnected. FLAC3D can handle that. This is not something that every software can do, but this kind of densification is something that we do all the time. It's totally useful. And so we've actually hooked up FLAC3D to be able to deal with this type of situation where you have one node that's disconnected from the adjacent zone. We just need one little command to make this work, which basically sort of reconnects these things. We don't do that in the model pane. We'll do that in the next video. But for now, just be aware that having these disconnected nodes is perfectly fine, and then we'll take care of it later. So basically, we're happy with what we've got here. what we've done is we've assigned group names to the faces. We've densified the zones around the tunnel. Again, there are other things we could do. We could assign constituent models and so on, but we'll just do that with commands later. So basically, we're happy with what we've got here. And all we need to do now is save it. So again, I will go File, Save Project, and saying the model state is unsaved. Yes, I would like to save the model state. I've already got one called Geometry. Let's call this Geometry 2. Okay. Now again, just before we finish, I'll mention again the state record. Because as I mentioned before, every single thing you do in FLAC3D emits a command, which allows you to potentially play this back again or modify it by hand or whatever crazy thing you want to do. And all these commands appear in the state record. Make this a little bigger. Now, in the sketch, the number of commands is relatively limited. It's just points that are created, lines that are created, groups that are assigned. In the model pane, you have a whole pile of commands because every time you click on something, it gives a command like zone select and arrange, and zone hide, or zone hide off, or zone select off, or so on and so on. So all the crazy clicks that I did during this example, it actually recorded as commands. This is generally not useful for a human being to be able to, read this and make sense of it. However, it's still not a bad idea to save that as a data file. So I can go here, right-click on it, and say Save to File as Data File. And let's call it Model Pane. Right, so if I wanted to, I could open up that Model Pane data file in here and look at it. And here's all of the commands that I did. Actually, it starts right from the beginning with the sketch set. So here's all the sketch commands. Here's where I was messing around with building blocks. Generate the zones from sketch. And then here's all this selecting and things that I was doing in the model pane. So I could theoretically type model new, run this whole file, and get back to the state that I'm sitting at now, which is useful. Or I can just restore this save file and be the same thing. So this is kind of like a safety mechanism. I have the save file, great. I also have the data file, great. It's not necessarily a terrible thing to have both. Okay, I think that is all I'm going to say about the model pane. In the next video, we will start actually running this model, applying boundary conditions, stresses, properties, and running it and doing interpretation.